Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC B1085 indicates a headlight low beam power source abnormality in the Honda Accord models from 2017 to 2023. This fault is related to failures within the headlight system, specifically within the relay control module, which is responsible for regulating power to the headlights. The relay control module is located near the fuse box, and its role is crucial for managing the electrical signals to ensure that the headlights function correctly. If the module fails or there is an issue with the wiring, it can lead to inadequate power delivery to the headlights, resulting in the B1085 code. This code can potentially affect safety while driving at night, making it imperative to address promptly. The troubleshooting steps outlined here will guide a technician through identifying and resolving the issue efficiently. The error description for DTC B1085 focuses on the low beam headlight power source's abnormal behavior. The headlight low beam system relies on the relay control module to function properly by routing power to the headlights as commanded by the driver through the combination light switch. The relay control module is situated close to the vehicle's fuse box, making it relatively accessible for repairs or inspections. This component acts as a control point, ensuring that when the driver activates the headlights, adequate voltage reaches them. In the event of an anomaly in power sourcing or signaling, this DTC is triggered, necessitating thorough diagnostic checks to pinpoint the issue. The integrity of the electrical connections and modules directly impacts the vehicle's lighting systems, thereby influencing operational safety during night driving. Identifying the possible causes of DTC B1085 is critical in the troubleshooting process. One of the primary suspects is a faulty relay control module, which can lead to improper signaling and power distribution to the headlights. Another potential issue could be a damaged wiring harness that may create shorts or disconnections, hindering the flow of electricity. Additionally, a defective headlight assembly could misinterpret the electrical input, leading to operational failures. Intermittent electrical connections due to corrosion or wear can also trigger this code by causing inconsistent behavior in the headlight operation. By understanding these causes, technicians can focus their diagnostic efforts more effectively and isolate the problem. When DTC B1085 is triggered, several symptoms can manifest, signaling a failure in the headlight low beam system. One primary symptom is that the headlights may not function at all, significantly affecting visibility and safety. Alternatively, drivers may notice that one side of the headlight goes off, which can be a clear indication of an electrical failure or bulb issue. Intermittent operation is another symptom where the headlights may work sporadically, presenting a challenge in nighttime visibility. Finally, the vehicle's dashboard may illuminate a warning light to alert the driver to the issue, serving as an early notification that maintenance is needed. Recognizing these symptoms enables timely intervention, preventing safety hazards on the road. In the first troubleshooting step for DTC B1085, it is essential to clear any existing diagnostic trouble codes, DTCs, from the vehicle system using the HDS or Honda Diagnostic System tool. Clearing the codes serves as a reset, momentarily removing previous fault reports to analyze if the problem is persistent. After this, the technician should turn the combination light switch to the on position. This action establishes a live condition that allows for real-time monitoring of the headlight system functions. It is recommended to wait for at least 6 seconds to ensure the vehicle systems fully acknowledge the switch activation. Following this wait, the technician should recheck for DTCs using the HDS. If DTC B1085 is still indicated, the process continues to the next step. If no DTC appears, it could mean that the problem was intermittent, warranting further investigation. Step 2 focuses on a crucial operation check of the headlights to assess their functionality after clearing the DTCs. Technicians should closely observe whether both headlights are operational when the light switch is turned on. A key aspect of this step is to ascertain if one side of the headlight goes off completely, as this will guide the subsequent diagnostics. If one headlight does go off while the other remains active, it indicates a problem that can potentially be isolated to the faulty headlight or its associated wiring. In contrast, if both headlights operate normally, the issue might not be linked to the bulb itself, but could instead involve the relay control module or wiring complexity. Based on the findings, technicians can determine the next appropriate action to take. In the third troubleshooting step for DTC B1085, technicians should swap the left and right headlights to determine if this changes the symptoms described in Step 2. This hands-on diagnostic technique assists in isolating whether the issue is with one particular headlight or if the problem resides within the electrical circuitry. If the symptoms indeed swap and the previously functioning headlight fails upon the swap, it confirms that the swapped headlight is faulty and requires replacement. This step enables efficient identification without the need for extensive wiring reviews initially. In contrast, if the symptoms do not change, the technician will need to explore other hypotheses about the failure, particularly inspecting the wiring or relay components linked to the headlights. In troubleshooting Step 4 for DTC B1085, a thorough check for shorted wires is essential. The first action is to turn the vehicle to the off lock mode to ensure safety during testing. Technicians should then disconnect a series of connectors, including Relay Control Module Connector A, 6P, Relay Control Module Connector B, 14P, and connectors for both the left and right headlights, ensuring a complete disconnection for accurate assessment. The next phase involves checking for continuity between designated test points to identify any shorts or grounding issues. Specifically, these points include Relay Control Module Connector A, pin number 4, and Connector B, pin number 2, each compared against body ground. Establishing continuity here indicates a short to ground, which necessitates repair actions. If no continuity is found, the relay control module itself may be defective and will require replacement, effectively resolving the electrical fault. After the necessary repairs have been completed regarding DTC B1085, a thorough final verification is needed to ensure that all systems are operational once again. Using the HDS tool, technicians should recheck for any outstanding DTCs and confirm that none reappear, indicating successful resolution of the issue. Next, it is crucial to test the functionality of the headlights to confirm they are illuminating as expected. Moreover, a brief test drive should be conducted to ensure that the vehicle behaves normally while on the road and that no dashboard warning lights are triggered during this process. This comprehensive verification step not only confirms repair success, but also allows the technician an opportunity to address any lingering concerns that may not have been evident during stationary testing. Preventive maintenance is a pivotal aspect of ensuring that DTC B1085 and similar issues do not recur in the future. Regularly inspecting wiring for signs of wear, fraying, or corrosion can help catch issues before they cause significant failures. Technicians should also make it a routine practice to test the headlight assemblies over time, as bulbs do have a lifespan and can fail randomly. Monitoring dashboard indicators enables prompt attention to emerging issues such as warning lights, which can signal low-beam failures like those represented by DTC B1085. Regularly scheduled vehicle maintenance checks can mitigate unexpected failures, ensuring the vehicle's lighting system remains fully operational, and thereby improving safety and performance in various driving conditions. In conclusion, understanding the implications of DTC B1085 is crucial for vehicle safety and functionality. A structured troubleshooting approach is necessary to effectively diagnose and resolve the underlying issues related to the headlight low-beam power source abnormality. Following each step with due diligence ensures that the technician can pinpoint the fault, whether it lies in the relay control module, wiring, or headlight assemblies. Additionally, comprehensive post-repair verification processes serve to validate that the problem has been effectively resolved and the vehicle's lighting system is functioning correctly. Finally, implementing preventive measures will not only help avoid similar challenges in the future, but will also enhance overall vehicle reliability, ensuring safe journeys for drivers and passengers alike. Please like and subscribe to the channel. See you next time.